Hey everybody, I've been spending my money again, and this week I bought a faulty Dell Latitude 5320i5 11th generation, 8 gigs. What? 8 gigs? They don't take the memory out of these, what? Oh, it's soldered onto the board. Okay, so that's why we have 8 gigs of memory. They couldn't take it off to sell it to somebody else. It says its 4 parts are not working, and as you can see in the title it says faulty. I'm going to take a picture of the board, get it onto the screen and see if we can diagnose this. Well, I scanned in the board, as you can see from the screen, and what was immediately apparent was that we had a fault in this area here. Oh, look at it. It does not look good at all. I am also concerned that this IC might have been removed. But let's get a look at it under a microscope. And looking at that damage section under the microscope, you can see that it is a complete mess. I'm not sure I'm going to be able to fix this. It looks like that area of the board is burnt up, and possibly there's a missing IC here. I'm not sure. I've looked at this board online and it seems that there should be an IC here, possibly removed already by somebody who tried to repair it. However, I have not had many modern motherboards on this channel so far, particularly with the USB-C input section. So what I'm going to do here is I'm going to go right back to the start with this motherboard. I'm going to go to the USB input section. I'm going to follow where our voltage comes in through there and see at what point we hit a fault. I've pulled up the schematic for this motherboard, and it seems that the two DC inputs for this are both Type-C connections. So we've Type-C 1 and we have Type-C 2. I'm not sure why they're both USB-C. Maybe there's an assumption that somewhere along the line you'll break one of them because they're so small and easily damaged. But two DC inputs, both Type-C, and you can spot those two Type-Cs here with USB 1, which is a Type-C here, and USB 2, which is a Type-C here. So what I'm going to do is I'm going to follow along the path of Type-C number 1 and see where we first hit trouble. From our schematic you can see here that we have our input, and then it hits two MOSFETs, so we have S1 and S2. So if I look at my actual motherboard here, I don't see any MOSFETs here. However, you should at this stage be able to identify the two MOSFETs involved. I'm going to pause this for a second, see if you can spot them. Okay, I realise now that that might have been a bit of a trick question, but the two MOSFETs I'm talking about are actually these two right here. As you can see on our Type-C number 1 connection, it connects here and comes on to this first MOSFET. This MOSFET is Q7407, and the next MOSFET, which is marked here as S2, is Q7408. And if we look, we have Q7408, and just behind that we have this MOSFET here, which I think this label applies to. It's a little bit far away, but Q7407 applies to this. Just to confirm that that is in fact S1 Q7407, I carried out a quick continuity test. So with the power off and in diode mode, I connected my positive probe to this little capacitor right here, and I connected my black probe to the pin number 1 of this MOSFET, and it measured 0.000. So this is definitely S1. So what I'm going to do next is I'm going to check for shorts at every point at the input section. So let's do that quickly now. So I introduce my multimeter in diode mode. I place my red probe to ground, and with my black probe I want to take a measurement at pin 1 of S1. So that's the source pin of S1. That's this one right here. And when I measure right here, I find that it measures 0.614. So there's no short at this point. Next I want to measure between the two MOSFETs. So once again in diode mode, I take a measurement here at the drain pin of the second MOSFET, and I find that it measures OL. So there's no short between the two MOSFETs. The next measurement I want to take is after S2. So we have S2 right here, and I'm measuring the source pin 1, 2 or 3. So I place my probe here and I find it measures 0.586. So no short here either. Now after S2, this voltage becomes labelled as plus SDC in and goes somewhere else on the motherboard. We can actually see on the motherboard itself that it comes through a current sense resistor and onto this MOSFET. So let me just mark that out. I've found plus SDC underscore in further down the schematic. It's actually this current sense resistor right here. But as you can see, this ISL chip, it's actually this 9538CH, is controlling these MOSFETs here. So if we look in closer, we can see plus SDC in. The next component is our current sense resistor P4401, which is this current sense resistor here. And after it passes through that current sense resistor, it then goes to, let me zoom out a little bit, onto this MOSFET here, which is PU4403. So we can see the marking on this here, PU4403. Now this is actually a dual MOSFET, but I'm not really interested in how it works at the moment. I just want to confirm that there's no shorts. We've already measured here at this point and found it was 0.586, so there's no short here or anywhere along this point. So this is coming onto pin 3, as we can see here. So I want to check the output of PU4403. So where I want to measure is one of these pins right here. To measure the output from PU4403, we need to measure at pin 5, 6 or 7. So these are 1, 2, 3, 4, 5, 6, 7 and 8. So 5, 6 or 7 is one of these 3 pins here. So I place my probe to pin number 6. I find it and measures 0.494. So no short here either. After PU4403, we can follow along on pins 5, 6 and 7, and we see that it then hits PU4404, which is this MOSFET right here, which again is another dual MOSFET. And after this, you can see up here that this is 19V underscore bat out. So I think this is the main power rail. So what we want to do is check our main power rail after this MOSFET and see what we're measuring here. As we can see from our schematic right here, pins 3 and 4 are the output pins of PU4404. So they're the pins that we need to measure on. So once again in diode with my red probe on ground, I need to take a measure of pins 3 and 4. So which pins are 3 and 4? Well, there's actually a dot here, so this is number 1. There's a little marker beside it as well. So pin number 1 is here, 2, 3 and 4. So 3 and 4 are these 2 pins we need to take a measurement. So placing my black probe to pin number 4, we find that it measures 0.001. So we actually have a short at this point, which is also corresponds to this point here. So it seems like we have a short on our main power rail. One thing I just want to remark on here is how more complex these are than the laptops we looked at earlier in the series. Like the earlier Toshibas that we looked at were literally just one inductor, 2 MOSFETs, current sense resistor and then your main power rail. But these now with the dual inputs have, you know, your USB goes to first MOSFET, then a second MOSFET, through a current sense resistor, onto a dual MOSFET, onto a second dual MOSFET, and then we have our main power rail. But I guess it's just to take it step by step and not get, you know, overawed by all of the different components. So we have a short on the main power rail. What's the next step? Well, as we've seen in many videos, if you have a short, the way to flush out the component that's shorted is to inject voltage and slowly increase the current until it heats up, and you can then identify the shorted component. We have a fair idea where the short is going to be from the damage that we observed earlier on the motherboard. But what I'm going to do is I'm going to treat this as if I have no idea where the damage component is. So let's go straight to voltage injection and see what warms up on the board. Next thing I'm going to show you how I set up the voltage injection. So first of all, we introduce our DC power supply. I connect my black wire to ground and I connect my red wire to the point at which we detected the short. Now it's more difficult to solder onto the pins of these tiny little MOSFETs, so what I tend to do is find somewhere like a capacitor and connect it to here. That's actually on the same path here. So with that connected, I switch my DC power supply on and I set my voltage low to start with. So I set it to 1 volt and I set the current to a limit of 0.500. So I'm starting it off very safely at very low power. And what we do is we touch around the board to see what heats up. If nothing heats up, just step up the voltage and the current, and then you will eventually find that the shorted component heats up and you can identify it. I stepped up the voltage and the current slowly, and I found when I had the voltage at 3 volts and the current set to 2 amps, a particular section of the board started to heat up. Now it came as no surprise that the area that was heating up on the motherboard was that section around where the damage was. However, what I found was there was a particular bank of capacitors that also seemed to get warm. So when I doused it in alcohol, you can see that this one in the center is burning off the alcohol more quickly than the others. Now I don't know whether this is because it is on the opposite side of where the short is, or if this is shorted also. So I doused those capacitors in a bit of flux, came in with my hot air station, and it gave a bit of resistance, but eventually came off. Now when I took this off, I actually smacked off the second capacitor as well, as you can see here. So what I decided to do was just take the two of them off the board, and that's what I did. With those two caps removed, I turned on the power supply again to see if the short was gone. However, it continued to pull 2 amps at 3 volts. So even though that one capacitor seemed to be burning off the alcohol more quickly than the others, it seemed like it was just a trick of the eye, and when I measured the capacitors, neither of them were shorted. With the capacitors removed, I injected power again, and it will come as no surprise to anybody that this whole section here is the area that was heating up. Now I'm sure at this point many of you are saying, why are you even wasting time on this? The board is obviously damaged beyond repair, and it's not going to be possible to get this back working again. But what I was hoping to achieve with this was to prove that I could disconnect the section of the board that was shorted, and by doing so I could plug in my USB and see that the main power rail was back online again. I did try and remove these inductors, these capacitors. I even tried cutting the tracks to the inputs to where this IC would have been, but nothing would take away the short on the main power rail. So I think it's somehow welded together inside in here. And that being so, I think that's probably about as much of my time as this laptop motherboard is worth. Here's a close-up of the damage so you can see just exactly how bad it is. I'm not sure even the best people at this could retrieve this situation. But that's where I'm going to leave it for this week, guys. Thanks for watching.